Once we understand a little bit about current and resistance and potential difference, we can begin to study circuits. The word circuit means circle or complete loop. In order to make a circuit, we have to have some components, like a wire, and we can draw a wire just by drawing a straight line. We'll also need a potential difference or a battery. So our battery will supply a potential difference. That's another way to say it. The voltage is the potential difference. And we'll need a load, something to power in our circuit. So maybe a resistor. So this is a load, which is also known as a resistor. So this could be a toaster, this could be a light bulb, this could be anything that you can imagine plugging into a circuit. Those are our symbols for those different components. So now to put them into a circuit, we want to make a complete circle. So we'll have to draw a battery. Now batteries have a positive side and a negative side. So the long side of your battery is the positive side. So connect that battery to a resistor, and then from the resistor we'll go back to the battery. And this is a complete circuit, and this is called a circuit diagram. Now if the positive side of the battery is the long side here, the negative side is the little short side of our symbol. So up here I will mark it as the positive, and then this one is the negative. And remember, we have a convention for current. Current flows from the positive side of the battery to the negative side of the battery. So when we think about current, we will consider it as the flow of charge from the positive side of the battery to the negative side of the battery. And so as this current flows through this circuit, there is a potential difference or a voltage across, a voltage drop, a voltage across that resistor. And if that resistor is ohmic, which all of the resistors we're going to study will be ohmic, then that means it follows Ohm's law, and that is that the potential difference or the voltage is equal to I times R. So we can analyze circuit diagrams to determine the current through each component.